This is Nicolas Joly. It's great to be with you today. I hope that you're all safe and doing well in these difficult times. I'm going to talk about a project that I did in summer 2018 for Excel Online. So I work for Microsoft at the MSRC, and I'm doing this recording from the UK, from home, actually. I'm living in Cheltenham in England. So I'm here to talk about an exploit that I did for Excel Online. So I guess that this presentation is going to take roughly about 30 minutes or so. Yeah, something like that. So I'm going to talk first about Office exploits that we've seen in the past years. And then I will describe a bit the Office Online server, what's going on there, how the services interact between each other. And then I will dig on the vulnerability that I found and how I managed to exploit it. And in the end, I will discuss a bit this exploit, see if this is the kind of things that we could expect to see in the cloud today. So I hope that you guys are going to learn a few things from this presentation, and I really hope that you enjoy it. So, all right, let's go. Office exploits. So the good thing when you work at Microsoft, at the MSRC, is that you see loads of exploits. By loads, I don't mean that we are going to see exploits on a weekly basis, but, you know, often, those are quite frequent. So Office exploits, we haven't seen any, I don't think so, in the recent years, but we saw some about 2 to 3 years ago. So I'm thinking especially of those affecting the COM monitors. In this case, we cannot really talk about an Office exploit, as those exploits were actually targeting Windows components. I did myself an exploit on one of these COM monitor, the obref monitor. So if you're curious, go check out my Outlook presentation that I did at Black Hat last year. Yeah, if you're curious. Exploits targeting Office core functionalities, those are quite rare. And thinking about it, the only ones that I can remember dates from like 5 years ago. Those were targeting the Office EPS font parser. The exploits at that moment were quite interesting, and I'm wondering why we didn't see that much press about it. So if you're curious, yeah, go check them out. Those are quite interesting as well. And when I wrote those slides, I initially forgot about the Stack Overflow in the equation editor. And why did I forget that? It's probably because the exploit was too simple. It was just a simple stack smash in a component where absolutely no mitigations existed. No such thing like ASLR or things like that. So the exploit was just trivial. But apart from that, I don't think that we've seen anything, at least in the recent years. What about Office Online? So when I initially did that research, I had never seen an exploit for Office Online. So we've seen bugs. I'm thinking, for example, about something that Juru from Google reported to us a couple of years ago. So the history of this vulnerability is that he found an issue in GDI, and he managed to trigger it through a Word document. So the vulnerability here was an uninitialized memory issue. And so we commonly agreed with Juru that we wouldn't service this issue as this wasn't posing a significant threat to our customers. And then he came back a couple of weeks later saying that this issue actually affected Office Online. And at that moment, this is a scenario that we just hadn't thought about. And so his proof of concept was just the same file copied 3 times. And when you looked at this copy on Office Online, you could see that a different picture was rendered each time. So here, we cannot really speak about an Office Online exploit, as I don't believe that Juru was able to exploit that, but he was still able to demonstrate it. So what about the Office Online server? So it's basically just an IRS server running on a fresh build of Windows 10, where loads of services interact between each other. So now, when I did those slides, I dusted off a VM that I used as a testing environment back in the days. And it's amazing to see that in this VM, there are almost more than 500 services running at the same time. So of course, this is a testing environment, so it doesn't really compare to what you would see in production, but that still gives an idea of what's going on there. So there are dozens of scenarios of usage for Office Online. The most common ones are, for example, when you received an email from Outlook on the web, and this email contains some attachments, some Office documents. So in those cases, you can just see those attachments in your browser, and then Office Online will render them for you. Another use case scenario is just when you want to edit some documents on the cloud. Then in this case, you will be directly interacting with the Office Online server. So one thing that I'd like to precise here is that there are two different servers. So there is the server that we call Office Online. This is a thing that you can find on the cloud, so the public doesn't have access to it. And there is another version that we'll call Office Onprem. And this one, you can actually download some builds, if I remember correctly, from November 2018, with just a simple Visual Studio subscription. If you want more recent builds, you need something like volume license agreements. So it's a bit more complicated to get, but if you're curious, if you want to test things, you can still get a copy. So let's come back to this project. So in 2018, so we are seeing all these exploits affecting desktop Office. And the question there is, all right, so we know that the desktop Office is vulnerable. There are some mitigations, but yeah, there are those exploits. But what about the online server? Is it just possible to get an exploit there? So this is the first question. Just make like some kind of feasibility study, see if one could achieve remote code execution on the server. And then the next question would be how would one do that? How much time would that take? Would we need like some things like, I don't know, symbols, for example, like insider knowledge, insider information? That's an interesting question. And then in the end, if we ever manage to exploit a vulnerability, what can be done better so that Office Online isn't to make Office Online a harder target for exploiter. So you see several questions that needed some answers. So I chose to go after Excel Online. I could have gone after a PowerPoint or a Word. I chose Excel. So there are several reasons for this. So before I joined Microsoft, I was working for a company named ViewPen Security, and at that moment, I've done a bit of research on Excel. I found a couple of bugs. I did a couple of exploits, but well, that's quite some time ago. And so I was already a bit familiar with the internals, how things worked there. I just had a couple of ideas for complex exploits that I've never really put in practice, and so I was a bit curious to see if I could get something done. And then, of course, I was curious to use Microsoft resources to look at Excel, because at that moment, this is something that I had never done before. So what is Excel Online? So as I said, Office Online is an IIS server, and Excel Online is just a service running in that IIS. So it's basically a huge DLL Excel server that contains most of Excel desktop core functionalities. So if you find a bug affecting desktop Excel, chances are that it will also affect the online server. So now we are in 2018, and the question is, how do we find a bug in Excel Online? So Excel has been fuzzed for over 20 years, and by finders, externals, also by the product team. Would it make sense for me to start running a fuzzer maybe on the cloud? I don't know. We need to think a bit about that. And also, what am I after? What kind of bugs am I looking for? Because Excel Online, there are some mitigations like DEP, ASRR, things like that. I need to get an interesting bug, at least interesting enough, so that I can bypass some mitigations. Also, I'd like to come back to one thing. Why aren't we seeing more exploits targeting Office core features, especially because of mitigations? Occasionally, we can have exploits that we call like one-shot exploits, that just a file that would trigger such a complicated exploit that every single mitigation would be bypassed at once. That occasionally happens. So the example that I'm giving here is from Chris Evans. It's quite an interesting exploit. He's targeting here an image format, and I think that he found a cool heap corruption, and he was able to exploit that heap corruption in such a way that with just one file, he managed to get a remote code execution, even without DEP, even with DEP and ASRR enabled. Those are very occasional exploits. We don't see them every day. What we see most commonly are exploits with, for example, JavaScript engines. So typically exploits for web browser, exploits where you can dynamically interact with your vulnerability, like typically with JavaScript. Or when you have a bug affecting the kernel, then you have certain APIs to play with that bug. So these are the most common things that we see. But for Excel, there's no such thing. There's nothing like a JavaScript engine. Actually, there is one, but you don't have access to it. No, in Excel, there is something cool. There are the formulas. And when you think a bit about that, Excel handles, I think, a bit more than 200 formulas. I don't remember the exact figure, but it's something around that. And when you think about all those formulas, then yes, it's certainly possible to get something good done with this. So think, for example, about all this string package. You've got everything there. If you want to manipulate pointers, strings, then yes, you've got all the functions you need. Everything that you can find, that you would be able to find in JavaScript, you can find it in just formulas, Excel formulas. So there are still a couple of things that are more difficult. I'm thinking, for example, of the fact that you cannot set a variable with the formulas. So say that you're in cell A3 and you type equal 3 plus 5, then cell A3 will be set to 8. But within that formula, you cannot set the content of another cell. So this is one of the limitations of this scenario. But there are still several other cool things. Like typically, I'm thinking of the lookup formulas that you can use to emulate for loops. So here, the reasoning is such. If we can find a bug, a vulnerability in one of those formulas, then it might be possible to exploit that issue with other formulas. And this is the idea that I had at the moment, but this is something that I've never managed to exploit myself. So this is where I'm starting. So now, how do we find an interesting bug for Excel Online? So here I'm going to use my experience. So I'm coming back a long time ago, basically when I started. I started in 2008 at ViewPen. So at that moment it wasn't named ViewPen already, but that was coming. And so I started in September 2008. And in October 2008, the next month, I remember there was a patch for Excel. And one of the vulnerabilities that had been fixed at that moment had been reported by the ZDI. So this was basically the first time that I was dealing with an integer overflow. So I remember going to that advisory and reading it probably 50 times to try to figure out some clues, as we were just clueless. We had no idea what was going on. We knew there was something that was affecting the rept formula, but apart from that, pretty much nothing else. So I do remember also diffing that thing, and I pretty sure that I spent more than 2 days trying to figure out what was the issue. I do remember seeing a multiplication that had been changed in the fix, but at that moment, I was a noob. I was literally a beginner. And to me, it didn't make sense that just a simple multiplication could lead to a vulnerability. Turns out the vulnerability was quite simple. The repeat formula takes 2 arguments and a string and a counter. And if you multiply the counter by the length of the string, it's possible to get that multiplication to overflow on 32 bits. And then you would then allocate an undersized buffer, leading that to either a stack overflow or a heap overflow. So at the end, I found it, and I was quite happy when I found it. But then the question that I asked myself in 2018 is how that bug had been fixed, because I did remember that bug. I was very curious of it. So I looked at the code, and then the bug was correctly fixed. 10 years after, no way this was still going to be a vulnerability. So at the time, the developers fixed that by introducing a function called cballoc_safe. And this function just makes sure that the math is correct and doesn't overflow. So let's have a deeper look at that function. Just some checks on the additions and multiplications using a safe in type. So nothing interesting anymore for us there. However, as we are looking for entry points in the code, potentially vulnerable entry points, what I thought at that moment was maybe I could just look for other references to this function and see who calls that. Because, again, I don't have much experience at that moment with formulas. I'm not sure of what is going on there. So I told you I work for Microsoft and I have access to the source code, but I still use IDA pretty much every day. And so I did look for a reference just doing a simple xref on the cballoc_safe in IDA, and this gives about 100 different results. And in those results, 3 of them point to a function called fnConcatenate. So you don't have the symbols, but I can tell you that the name of the function is fnConcatenate. Let's look at them. And more particularly, let's look at the last one. And when you look at the code in IDA, you see a bunch of multiplications and additions. This is done right before a call to cballoc_safe, which is supposed to check additions and multiplications. And so when you look at that as a bug hunter, you think like, okay, there is something here. It's not possible. This is too weird. So the next thing you do, obviously, is trying to figure out who calls this function. And then you, just by doing a simple xref, you find a mention of a string named textjoin. So at that moment, I'm like you, I have no idea what this is. So let's look on the internet. And a quick search gave me this documentation from Microsoft saying that textjoin is just another formula using concatenating cells and strings. So pay attention to the first argument here, delimiter. So this can have several forms. And here we are interested in the reference form. And this is where things get cool. So when you look again at that assembly, you think that, Excel has been first again for over 20 years. Something like that, it's too big. Definitely missing something. And again, there is something that I don't see. These are my first thoughts, literally. And then just looking at the code, you can see the history. And it turns out that in 2015, some new code had been added to that formula. And at that moment, the developer decided to support 3D references. So references on 3 dimensions, column, row, and spreadsheet. And now, once you have everything in mind, it's very easy to get a simple POC. And the formula that you can see on the screen right now will trigger, I believe, an access violation, a write access violation in a vulnerable version of Excel. That's cool. We now have our bug. Let's see if we can exploit it. So most of the time, the problem with those issues is that you are going to hit the end of the page quite quickly, and you won't be able to exploit it. Because usually you trigger your integer overflow, and then you allocate some space on the heap, and then there are several loops. So in this case, there are like 3 different loops, which will be trying to write data on the heap. So we need to get out of these loops. We need to find something where we can safely exit and control the corruption. And it turns out that it's actually possible in this scenario. There is something that where we can abort here. So if one of the cells that we are trying to concatenate contains an error, Excel will see that error and will just raise an exception in this function. And so in the end, we will just exit the loop without hitting that end of page. So this is a good thing. That means that we have a controllable heap overflow. And this is quite good. One thing that I didn't mention is that we are writing pointers to strings, not just bytes. So let's look a bit more at this issue. So there are a few constraints. Of course, constraints from Excel, for example, the number of rows or the number of columns. But there are also something else. As we are forced to trigger an issue, an error, an exception, Excel at the end of that function will just free everything, which means that those pointers that you've just written, those pointers that you are using to overflow the heap, those will now point to freed memory. And when you think a bit about that, you initially have an integer overflow that leads to a heap overflow that now leads to several use after free. So at first sight, the primitive looked good, but looking better, well, it's not the best bug ever, but it's certainly possible to get something. And then comes the exploitation. So probably the first thing that you'll try to do is get a leak, a memory leak, because you need to bypass ASLR. So here, the memory is quite easy to get an exploit done. It's because Excel stores string in memory with a counter on 2 bytes followed by the string itself, which means that if you override that counter, then you will be able to read past the bounds of the string. So once you've got that in mind, you can think about a scenario where you would override that counter to that string length with a pointer, and then you would be able to read past the bounds of that string, potentially reading things like vtables, pointers, something like that. So at that moment, the scenario is quite simple. Just spray the heap, make some holes, trigger the vulnerability, and then yeah, let's cross fingers. Let's hope that there is something cool to leak. But I'm not very scared of this, so it's probably going to work. And if you've ever done something like that before, if you are an exploit writer, you know that things will never go according to the plan. There is always something that you haven't thought of. And in my case, it was the undo or Control-Z. And this is quite cool, actually. When you think about that, when you type something in a cell, you can always revert your change. And then Excel will just keep everything in memory, which means for us that those strings, they won't be freed like this. No, and I totally forgot about that. I didn't even consider this at the beginning. So it took me a couple of at least hours, good hours, probably days, to realize what was going on. I just couldn't free my strings. So once you've got that in mind, there are several scenarios where you can work around. So the first scenario would be to exhaust that undo stack. Just enter so many actions that in the end Excel would be forced to free those strings. The problem with this scenario is that it would force you to make so many allocations, and then the heap would be, a bit unstable. Your exploit wouldn't be reliable. So in the end, I didn't opt for this scenario. I went for another scenario. So things have changed since 2018, but at that moment there was a button named Calculate Workbook. And using that button, you could actually commit your changes, which means that Excel would just free all those strings, everything that you wanted to be free, and it wouldn't be possible for you to revert those changes. And so this is what I did. So now I've got my leak. I know that overwriting a string length with a pointer is enough for me to read past the bounds. And this is what it looks like when you do something like that with Excel Online. You literally get some Chinese results in your cells. And now, coming back to the string package, this is where you can use it. You use the string functions to just play on these Chinese characters, which are NVN pointers. So this is cool. Now, what are we leaking? I believe that the first thing I did once my leak was working was to check every single formula, see if there wasn't one that could potentially allocate some C++ objects with the tables. Yeah, that would make sense. I went over them all. I didn't find anything. That doesn't mean that it's not possible. There are some really complicated formulas, like typically I'm thinking of the pivot tables formulas. Those are quite complex, and I wouldn't be surprised if in the end it was possible to get something allocated with them. No, I went for a different scenario. I went to play with charts and graphs. So again, there are dozens of charts, and each of them leads to allocate a different object in memory. And those objects are C++ objects with the tables and pointers to other objects. In my case, I found a graph with a pointer to a title object, and that title object had a pointer in its structure to a string object. And that was cool, because as I was overwriting the heap with pointers to string, I could potentially overwrite that object up to overwriting a pointer to a title object, and then overwrite that final pointers with some control characters. My intention at that moment was to get a read primitive so that I would be able to read data from Excel serve, basically disclose the entire binary. Turns out that this scenario didn't work for various reasons. I could get it to work sometimes, but it wasn't reliable enough. So in the end, I failed to get a read-write primitive. I just opted for more simple scenarios. I was assuming that I knew already Excel serve, which is the case when you are attacking Excel on-prem, for example. You've got access to the build, so you can work around, you can have an idea of where your gadgets are. And in the end, you just replay a static wrap. That works. And so in my case, I just managed to trigger a vtable call on one of those graphs to get code execution. And the exploit there was quite cool because I just needed to resize one of the graph to get code execution. So you know what? I'm going to show it to you. So I've got a demo here. Hopefully it will work. No reasons. So I'm going to comment it quickly. So this is the Office Online server that you're seeing, and this is the Excel Online process. So the best way to interact with it is just create a blank email and add an Excel file to it, and then preview it so that it will be sent to Excel Online. Then we go to edit mode, which will enable us to interact with the server. And so here we go. So now first thing I'm doing is spray the heap and make a couple of holes so that later I can fill those holes and trigger the vulnerability to override the counter of a string. And this is what's happening here. So we got successful, we got the exploit, the vulnerability succeeded because we've got that string showing weird characters. And here we go. Here, this is what I call my heap visualizer. So I'm basically looking at the heap using Excel cells. So let's come back to the first spreadsheet. Now let's make more holes and let's insert some graphs. So this is to be able to leak something. This is to be able to leak a vtable. So if I remember correctly, yes, there are two graphs here that are put there, just to be sure that it's going to work. Let's come back to my heap visualizer. Did that work? Yes, it worked. Because right now you can see those vtables, you can see those pointers. So we just need to trigger the vulnerability one last time, so a third time, to overwrite one of these vtables and hopefully trigger code execution. And if things worked, at that moment, we just need to resize one of those graphs, to trigger our payload. Let's see if we were lucky. Turns out that, yeah, we were lucky. Magic of the recorded demo. So let's discuss a bit this exploit. Is it the kind of thing that we could potentially expect to see on the cloud? I'm a bit skeptical on this, especially when I'm thinking of all those memory manipulations. You need to sculpt the heap. You need to be able to put some holes to trigger your vulnerability. But the problem is when you attack a production environment, there will be all those users working on Excel spreadsheet at the same time. So to me, it sounds a bit complicated to be able to reach a heap state that could potentially be useful for your exploit scenario. That doesn't mean that it's not possible. Definitely not. And the thing is, with IIS, if your process crashes, then it would just restart it for you. And in the end, you just need one lucky try, to get your payload executed. So I found a bug. It was definitely not the best bug. I actually found two. The second issue was affecting the forecast formula, and it turns out that at that moment, those were not available on Office Online, so I didn't really look at them in the exploit scenario. But the thing is, in the end, you just do with what you have. And so I had one bug, and I managed to exploit it. I'm quite convinced that by putting more effort on it, it's possible to get something really cool, something where you could potentially leak and read the entire Excel binary. I didn't do that because I was limited on time, but that's definitely something possible. And of course, so this raises more questions. So it's possible to do that on Excel Online. Can we do it on desktop Excel as well? Is it possible to craft an Excel file so that everything will be done at the same time, bypass ASR, bypass DEP, etc., and then add even an exploit for protected view? I don't know, possibly. And then, of course, once you have control on the server, what can you do? But then this will probably be subject for a next presentation at Black Hat. So I hope that you've enjoyed this presentation, and if you have questions, I'm always there. Thank you all. Thank you for your attention. Hope you had a good moment with me. Thanks. Well, thank you for listening. I hope you had a good time. So, taking any questions? You must have questions, I'm sure. Can I speculate if this same type of attack could theoretically be performed on something like Google Documents? I have literally no idea of what's running on the Google Cloud, so I cannot answer that. I guess maybe yes, but I don't know. Should ask the Google guys, actually. They must know about that. Any other question? Come on, don't be shy. Hi, Evangelis. Can I upload this box? No, but well, you've got enough to build your own proof of concept if you're curious. I believe that you can understand that I'm not going to provide the exploit. Is it likely that Word would be subject to the same vulnerability? So, the bug that I exploited was in Excel. So there was a formula in Excel. There is no such thing in Word. Is there any vulnerability in Word that could be exploited? Then, yeah, potentially. I don't have any in mind, but I mean that you can potentially get the same sort of thing in Word, but definitely with something else. Do I know if detection capabilities with Azure Sentinel exist? This is actually a good question. I am not aware of anything like that. There would be detections on the behavior of IIS, for example, things like if it starts a random process like CMD or this kind of thing. Yeah, that would raise some alarms. But detections based on like typically malicious Excel formulas, no, I don't think that there's anything like that. Any other questions? I like the question on the Google documents, by the way. You should definitely ask those guys the same questions. Anything else? Come on, don't be shy. I cannot see you. In my exploit attempt, did I trigger any forensic logging from the exploit? So I was testing on my own environment, so there was no such thing there. I mean, there wasn't any AV or anything in particular there. So no, that exploit didn't trigger anything. But as I said, I was loading a library from a remote share. And if you actually try to do that in your exploit, you're probably going to raise dozens of different alarms if you do that. Anything else? I'm taking advantage of this Q&A session to remind you that we've got job offers in our team in Cheltenham in the UK. So if you want to work with me, then you're most welcome to ping me on Twitter or just look at the job offers that we've advertised. Uh, I would love to get your CV. Any other questions? Thank you anyway for the great feedback on this chat. I can see that you enjoyed the presentation, so that's good. Anything else? Well, if there are no other questions, then I think I'm good to leave you then. Thank you all for following me. Have a great day, guys.